Okay, next up in our View menu selection is the Locals window. Like last time, once you click on it, it may appear on a different location in your screen or simply appear as a floating window. Like last time, let's click and drag the header and bring it down to the left until you see the shadow of where the docked window is going to appear. This can be quite fiddly and inaccurate, but move the window around until you get there. If it snaps into a position which leaves very little of the window visible, adjust the right-hand side of the frame until it takes a better proportion. This window is so incredibly useful. You use it in break mode to get a view of all the local variables being handled in the procedure which is in progress. We saw in the last lecture how we can use the immediate window to query local variable values, but you'll see the locals window is a significant improvement on this. Let's step through our Hello World sub again. Keep your eye on the locals window. As soon as we start stepping through it, we see that our string variable appears there. We see that it takes an empty string as its value, also known as a null string. But as we step through the code, once we get to the line where the variable is assigned our message as a value, the locals window updates to show us this is indeed the case. This is really valuable because it gives us a continuous dynamic view into all the variables in our sub, and we can see them all laid out together at the same time. A tip you may find handy is that the order in which variables display in the locals window will match the order in which they are declared in the procedure. Once you graduate to coding procedures with many variables, you can choose to organize them systematically so that they are easier to monitor and track using the locals window. It may be hard to imagine how big a deal this tool is, but once we handle large numbers of variables, you'll see it becomes absolutely indispensable for examining, testing, and debugging your code. The locals window has one limitation that's worth knowing about. The statements which initiate a procedure run are known as procedure calls. And so we describe the initiation of a procedure run as calling a procedure. You'll learn that it's very useful to design procedures so that they can be called from inside of other procedures which are already running. And other procedures can be called from inside them in turn. If you watch the blockbuster Inception, you're probably a step ahead. Let's see this in practice by creating a simple chain of procedure calls. You'll see here we have three subs. Proc1 has a line calling proc2, and in proc2 there is a line calling proc3. Let's just quickly step into proc1 by keying F8 and seeing how that all executes. You start in proc1, but when you execute the proc2 call, you jump into the proc2 sub. And when you call proc3, you jump to there. Let's be clear. When you call and move to the new procedures in this way, you have not cancelled the remainder of the instructions which were yet to be read in the prior procedure. Those earlier procedures are still in progress. Let's continue stepping through with F8 to see what I mean. We next read the debug print statement in proc3, and sure enough, we get our message shown in the immediate window. After that, we reach the end subline, and when we execute that, we appear back in proc2 on the line just below where we had called proc3. Continuing the step through from there, we see we continue to that sub's debug print command. By continuing ahead, we finally arrive back at proc1. Now let's do this step through again quickly, but this time keeping our eyes on the locals window. All these subs declare one long integer, and each one assigns it a different value. Nothing fancy. But as we move into the different procedures, we see that the locals window only displays variables which are accessible to the procedure currently in progress. Imagine, though, that you're in a situation where, in order to fully understand what's going on, you want to know what the variable values are for a sub which had been called earlier. It looks like the locals window won't be able to help you for this task. If you've had the bright idea of using the immediate window to get around the problem, unfortunately this won't work either. Like the locals window, the immediate window can only interact with variables which are accessible to the procedure which is currently underway. In this situation, you want to make use of another tool called the call stack window. Like the other tools we're using, you'll find this in the View menu, but it's different to the others because it is only accessible when procedures are running in break mode, and it is not possible to dock it to the main IDE window as we've been doing with the other ones. Clicking on the menu option list, or loading it with Ctrl-L as a shortcut, opens this little pop-up window, and it shows us our current call stack. Call stacks are a list of all the active procedures which have been called, arranged in the order by which they have been called, such that the very first procedure call is at the bottom and the most recent procedure call is at the top. We are unable to keep this window in view while we step through code, so let's close it for a minute and continue until we return to Proc2. If we open up the call stack window again, you can see that the list has changed, and now only Proc1 and Proc2 are visible. This tells us that the call stack is not a record of all the calls which have been made in a session. It is instead a record of all the active procedures which are underway and the order in which they will be returned to on the way to completion. Any additional procedure calls which are yet to be executed will not show up in the call stack. For example, if I add another Proc3 call after the debug print line, then reload the call stack window, nothing has changed because we're still only in Proc2 and we have not called Proc3 yet. You can see how the call stack window can be a helpful tool in its own right. Sometimes you'll want to double-check or map out the call sequence in a long chain of procedure calls. But in this case, with the locals window, it also helps us to keep visibility of variables declared in procedures further down the call stack. Now that we're in Proc3 again, we bring up the call stack window. If we highlight Proc1, then click Show, we can see that the locals window now shows I as our local variable, correctly showing the value of 3. You can also see that an indicator has appeared at the line by which we arrive at the procedure which is currently underway. We are currently in Proc3 though, not Proc2. So what's going on? Well, since we only enter Proc3 via Proc2, from the point of view of Proc1, we reach Proc3 from the call Proc2 statement. This marker helps make clear how much of the Proc1 code has executed up to this point, which is important for having a clear picture of what's happened and what's yet to come for Proc1's variables. Now, it's important to understand that we have not just found a way to bring Proc1 variables back into the locals window. When we click the Show button in the call stack window, we are in an important sense back inside of Proc1. If I try querying the value of I in the immediate window, I now do get a response, but no longer get one for the value of k. I can also use the immediate window to alter the value of I. But if I key F8 again, the next line executed is still in Proc3, and that's confirmed if I bring up the call stack again. These options give you a lot of flexibility to review and debug code, but they need to be used with care to make sure you only ever examine or change the exact variables you're interested in.